In this lecture, we're going to learn about overloading with const parameters by value. And we're going to look at a simple example here. One might think that these two functions here are valid overloads in C++. Because the types really seem different, we have int parameters in here and we have const int parameters. The thing is, the compiler is going to think these two functions are really the same. And the reason is, we're going to be passing copies. And marking our parameters as const here isn't really going to make a difference because we're going to be making copies anyway, and the const in our parameters here isn't really going to be protecting original variables. We're going to be making copies anyway. So these two overloads are really going to do the same things in the eyes of the compiler. And it is going to treat them as one. So it's going to say we have two identical definitions and you're going to get a compiler error. And this is what I want you to be aware of. If you're trying to do something and get a compiler error, you're going to know what is happening. So if for some reason you want to pass const parameters to your function and you don't want people to be able to modify the parameters you pass to them, I would recommend to put the const keyword even in a definition like we are doing here and not put that in place in the declaration like we have here. Because the const in the declaration isn't really going to mean anything because we're going to be making copies anyway. This is the message here. Don't do what we are doing on top here by marking our parameters as const in the declaration here because this is really useless. This is not going to protect the parameters you pass in here because those are going to be copied and what we will be modifying in the definition are going to be copies. Now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working directory. The current project is overloading with const parameters by value. We're going to grab our template files and put them in place. Let's do that. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. Okay, we have the project opened. We can open our main CPP file, close the left pane here, and remove what we don't need from our main CPP file. And we are going to put in our function, which is going to take parameters by value, and the parameters are not const. And if we try to set up an overload that takes const parameters from this, we're going to see what happens. Let's do that. We're going to pass const parameters. And if you do this, you're going to see that the Visual Studio Code editor is not going to have a problem with this. And if we build this program, we are going to have a problem because we are redefining max. The compiler is going to think that these two functions are really the same. And the reason is the compiler is going to see that we are passing value. We're going to be making copies. The changes we do inside these functions are not going to affect anybody on the outside of the function on these parameters here. So they really are equivalent and the const here is almost useless. So the compiler is going to think these two functions are equivalent. You can't use them as overloads. You're going to get a compiler error. If you want to use any of these guys, you're going to have to let go of the other one. So for example, if we take out the one without the const keyword and try to compile the program, now it is going to work. Let's do that. You see that the build is good down here. Okay, this is something you need to be aware of. If you have a setup like this, you're going to get a compiler error. The next thing I want you to see is that if you happen to split your function into declaration and definition, you can even leave out the const in the declaration and only use const in the definition if that is making sense for your application here. Let's show you what I mean. I am going to put my definition in here and I am going to take out the body from the declaration and I am going to say int a and int b and only use const in the definition here. Because sometimes this is really useful and you don't want people to modify the parameters that you pass to them. So you can go in here and add this level of protection. Now that we have this setup here, if they try, for example, and say ++a, modify a in any other way, or b here, we're going to get a compiler error because we have no business modifying this guy because it is const. But our declaration is really meaningful because we know that we are passing by value and we are really going to be working on copies. Hopefully this makes sense. This can be confusing to many beginners. Now, if we try to compile, we're going to get a compiler error because we can't modify this guy. It is const. Okay, and we're going to see that increment of read-only parameter a. We have no business doing this. But if we take out this const, we're going to be able to modify it because it is a non-const parameter passed by a value here. Let's build again. We're going to use GCC to do that, and you're going to see that the build is good. This is really all we set out to do in this lecture, showing you that overloading with const by value can really throw you off because the compiler is going to think that your functions are equivalent and you're going to get a redefinition error. Okay, now that you know about this error, you're probably going to be safer from it in your career as a C++ developer. We are going to stop here in this lecture. In the next one, we're going to see how we can overload with pointer to const and const pointer. Go ahead and finish up here and meet me there.